we are going to look at one more example trying to put together a lot of the same ideas that we've been talking about throughout this course. We're going to particularly look at probability distribution. So suppose that data collected from a local K through 12 school district finds that roughly 40% of students miss exactly one day of school. 21%, oops, let me change my color. 21% of students miss exactly 2 days of school, and then 11% of students miss 3 or more days of school. First thing that I want to do is create a probability distribution for the number of days of school missed for students. So I'm going to make a little table right here where let's talk about the number of days missed, and then the probability with which they occur. So they told us exactly 1 day of school. If we miss 1 day of school, that was 40% or 0.4. So there's my first case. 21% of students miss exactly 2 days of school. So 2 days of school missing, 21%. And then 11% of students miss 3 or more days of school. So for 3 or more days of school, the probability of that occurring, and let's actually say 3 plus for 3 or more days, would be 11% or 0.11. Now, if I pause and think about a probability distribution, I can actually look at this, and if I add these together, 0.4 plus 0.21 plus 0.11, if I add these together really quickly, I'll notice that I don't actually end up with exactly 1. Oops, I end up with 0.72. So that means that there's an outcome missing right here. I haven't talked about every single potential outcome. And if I look, I've got miss exactly 1 day of school, 2 days of school, 3 or more days of school. There is one case that I haven't talked about, and that's if I miss no school or 0 days. So I can actually fill in the blank here. I can figure out how many, or what's the probability that they missed exactly 0 days. Well, I know that all of these together have to add to be 1. So essentially, these 3 cases over here serve as the complement to missing 0 days of school. So I can find the probability of missing 0 days of school by taking 1 minus 0.72 should give me 0.28. So the probability that I miss 0 days of school would be 0.28. And there's my probability distribution. So let's take a look at the next few problems about this probability distribution. Part B says, what is the probability that a randomly chosen student misses at least 1 day? So when we say at least 1 day, at least 1, that means 1 or more. So it could be 1, it could be 2, or it could be 3 plus. So if I look back at my probability distribution, let's get rid of this highlighting here so we can focus on this. If I miss at least 1 day, well, 1 is at least 1, so it could be 40%. 2 is at least 1, so it could be 21%. And 3 plus is at least 1, that's 11%. All 3 of these are possibilities, so it could be 1 or 2 or 3 or more. Now, what's nice is these are mutually exclusive events, meaning there's no overlap. So I should be able to just add these probabilities together. So when we say 0.4 plus 0.21 plus 0.11, we actually calculated that number right above to get 0.72. So the probability that we miss at least 1 day would be 0.72. Moving on then to part C, it says, what is the probability that a student chosen at random misses no more than 1 day? So I've kind of rephrased my question now. I have a different case when I say no more than 1. When I say no more than 1, so first of all, you are not allowed to be more than 1. So you could be 1. So you could miss 1 day of school, or if you're not allowed to be more than 1, well, then you could be less than 1. You could miss 1 day of school, or you could miss 0 days of school. So probability that I miss 1 day of school or 0 days of school. And again, these are mutually exclusive events, meaning that there's no overlap between the two. So I'm just going to add these two together. So in this case, I'm going to add that 0. Oops, not that one. I'm going to add 0.4 plus 0.28, the probability that I miss 1 day and the probability that I miss 0 days. So 0.4 plus 0.28 gives me 0.68. There is my probability. 2 more quick questions to wrap this section up. Part D says if a parent has 2 kids, so okay, well now we're talking about 2 kids in this school. What is the probability that both kids will miss some school? In other words, both will miss at least 1 day. So what this is really asking is this kid misses at least one, and this kid misses at least 1. And this is an and probability, which means we're going to be multiplying these. And actually, we found these probabilities right above. The probability that a student misses at least 1 day, we said at least 1 day, that probability was 0.72. So the probability that a student misses at least 1 day would be 0.72, and the probability that the other student misses at least 1 day would be another 0.72. And if I'm looking for an and probability, I'm going to multiply these together. So 0.72 times 0.72, that gives me 0.5184 for my probability there. Now, the last question I want to answer, I think, is perhaps the most interesting. It says, what assumptions did you have to make for Part D, and are those assumptions reasonable? I didn't mention this kind of on purpose because I wanted to talk about it here in this part right here. The formula that we used up here, we said probability of A and B is equal to probability of A times probability of B. We talked about this in this chapter. This only works if A and B are independent. So what I need to ask myself is, if we have 2 kids, are the events that them missing school, are they going to be independent of each other? So imagine this. I've got, a 3rd grader and a 5th grader, and if one of those kids is sick, does that mean that the other is more or less likely to get sick? Most likely, probably, because they're living in the same home. They're going to be in close contact with each other. So we assumed that the 2 kids getting sick or not sick, or let's say missing school. I'm thinking about missing school as getting sick, but missing school are independent. That was the assumption that we made. And we said, probably not. You're probably, if you're missing school, most likely it's because you're getting sick, and it's because if one student gets sick, their sibling or whoever they're living with is perhaps also more likely to get sick. If one kid gets sick, the other is more likely to get sick. Now, what that means is I really probably shouldn't have used this formula up above here in Part D. Unfortunately, there is no other way for me to answer this question. I would need a little bit more information about the likelihood that 2 kids living in the same household both get sick, but I don't have that, so we're just going to have to go ahead and use the shorthand in order to answer this question.